You're watching a Maintenance Parts Management Challenges Asset Management webinar. This is part of the Asset Management Webinar Bridging the Gap series, sponsored by Asset Acumen Consulting. Welcome everybody to this Maintenance Parts Excellence Challenges presentation. It's my attempt to send you a bit of information somewhat compressed in the course of an hour to give you a sense of my perspective on maintenance parts. John, you actually sent me a note and said, well, what's the right way to decide what part to stock and not to stock and those kinds of things? And boy, I wish that was a simple answer. You're going to see after this hour, it's not a simple answer, but obviously that's a key money question. And I'm happy to sit down and work with people on how to do that. You know, at another time. Again, if you were to take the 2-day program, you'd learn more about some of the dynamics of that, but it's not a simple question. And probably the biggest issue around that is culture. There's so many people that just don't recognize they have a role to help maintenance parts be successful. And so that's probably the major issue when you get in behind what it's about. All right, I'm not going to spend a lot of time on this. You can read this at your leisure, and obviously I'll send you a copy of this. But I have about 42 years. I probably have more than 42 years, but after 40, I think people stop giving up trying to keep count. Maybe after 20, they think that's too many years in this space. But I've had 42 years at IBM in this space, and I've had 3 years on my own since. And one of the pleasures I had when I was at IBM is I was the country parts manager at IBM Canada. To give you a sense for that, we managed about $100 million inventory. We had an inventory turnover about 1.5 times. I had a staff of about 130 folks across Canada that I looked after. And so a lot of my insights and perspectives are from that experience and some of the consulting that I've done since that. And I've been in consulting with IBM since 1999. So that's over 20 years as well, and multiple parts opportunities, I guess, to consult in parts as well. Just to give you a sense of some of the things that are offered by myself at the University of Toronto, we teach a physical asset management program. I've had a number of cities in Canada that are focusing on the same thing, but more from a municipal asset management perspective. So I rebranded most of the physical asset management as municipal asset management. Many clients want to know what leading practices are, so we have an asset management leading practices program. I am an RCM2 practitioner, so if you're interested in reliability center maintenance, whether it be RCM2 or RCM3, I can help you make that happen. We already talked about the Maintenance Parts Excellence Program, which originally was 2 days, and I've now taught it in 3 days and 5 days with a colleague from the university, professor there. Recently, about a month or so ago, I put out an IT and IoT asset management training seminar 1 day. There was a fee for that as well. We just did it again about 2 weeks ago. And many clients are looking for KPI help, and so I've helped them with that. So I'll give you a sense of that. Some of the books that I've been associated with, Maintenance Excellence, I didn't participate. I didn't write that, but I certainly used it a lot. The Asset Management Excellence, I was the main contributor to that particular book, although not listed as an editor. And then there's an Anatomy of Maintenance Parts Management Excellence that I've been writing for the last couple of years. It's written, it's actually edited. We're just in the process of negotiating publishing for that. So it's maybe, 6 months out or so. What I plan to cover today is what is maintenance parts management? And again, we're talking about from my perspective, why is managing maintenance parts important to your enterprise? Who does maintenance parts serve? And it's amazing who it serves. You may think it's just the technician, but it actually serves a number of different roles in the organization and how that plays. Who can contribute to parts management success? And the simple answer is probably almost everybody. And I'll explain what I mean by that in a couple of charts. And what could be the complexities of maintenance parts management? Well, they can get quite complex. And we'll talk a little bit about that, at least in this hour. An introduction to prioritizing maintenance parts management issues and opportunities. So I'll show you a program that I've used, a very similar program that I've used even when I was consulting at IBM and used since. And so we'll introduce the notion of this maintenance parts excellence pyramid. which I rebranded a little bit after I left IBM. High-level maintenance materials management model. So I'm going to introduce some models. So here's the other issue about maintenance parts. There's no one single model that I've come up with that explains it all very well. We're also going to talk about, so there's a materials management model, there's an inventory management model. I'll talk about asset lifecycle, a little bit of KPIs, some typical KPIs that I used quite successfully when I was running the IBM operation. And then I'm going to introduce you to this notion of a maintenance parts excellence, the pyramid, I guess, but what the leading practices are. I'm going to organize it by the 10 elements that are in that pyramid. And then I guess after we've shared a fair bit of that with you, we'll talk about what next steps would be. And of course, that's going to be different for every organization and where you are. So that might be a very personal discussion that you may decide on your own. One of the key questions people often got confused with is, well, Don, you're calling it maintenance parts management. Some organizations call it after product sales, parts support, others call it MRO. And I came to the conclusion after looking at these in many different ways that I'm just going to call it all maintenance parts management. Even though it could be, for instance, Bombardier sells trains and now they've got to sell parts for trains and they've got to sell maintenance for trains and things like that. Well, that's after product sales. Or you've got maintenance, repair, and overhaul, which is a traditional consideration for plant maintenance. They call their parts MRO. We'll just call it maintenance parts management to make things a little more simple for everybody. It's still really about having quality support, having quality parts, the right quantity to the right place within the committed timeline. It's still typically that maintenance costs are about equal or par to the actual, or parts costs are rather equal or par to the maintenance costs. And then there's about perhaps 20% of other things. So when you think about all the maintenance and focus on maintenance and all the things that happen to that, okay, well, there's cost to that, but there's also equally parts costs. And it's not just the cost of the part itself, but it's the cost of keeping the part available in some sort of infrastructure that can be made available to the technician when he needs it. And so at some level, we're going to talk about, well, why do we even stock parts? Why is this important? What's really going on as I'm a technician standing at one end of the counter? What's really going on at the other side of the counter? Now, I was both a technician, a maintenance technician, and a parts person. So I have to admit that when I was waiting for parts, I just thought it was marvelous how they could organize all that stuff in those shelves on the other side until, of course, they didn't have the part I wanted. And then I'd be, well, how come? What was wrong? Why could they not possibly have known that? And I didn't really understand at the time what the issues were. If you were to write this down, and we simply don't have time today, we'll go through this exercise in the 2-day program, but if you were to write down on a piece of paper, why do we stock parts? Some of the answers I've gotten in the past might be, well, we stock them in the event of poor quality parts. I have a part, but if that one breaks, I need to stock another part. Perhaps I stock parts to be available to reduce purchase lead times, so I just need them so that we can negotiate better lead times. Keep assets operational and just in case. So I have my assets running, and if they fail, I need the part just in case it fails. Minimize mean time to repair. Plan maintenance with available parts so I can do better planning if I know I have the parts in stock. Parts based on past usage. That's why I stock them. Hey, we used one before, so we better stock one again. Reduce lead time on urgent purchases. To save money, bulk purchases if applicable. Reduce expediting fees. Now, I'm not going to say any of these answers are necessarily the right ones. These are just answers other folks have given in a class that I've taught. And the last answer, and it happened to be a client involved in some Department of National Defense stuff. They said, well, we also need military spares. So we need, of course, asset lifecycle and just in case. And we may never need the parts till we actually start using the asset, but we need them just in case. What are the biggest challenges? And again, I'd asked that to a lot of folks, and maybe a different set of group of folks would have said, not having a part in stock due to asset feature obsolescence might be an issue. That's a challenge for them. Or parts transaction transfer between stock rooms and to a work order. So how do I get it from one stock room to another? And how do I get it lined up for that work order? Do I have the parts? Do I have the tools all lined up, perhaps, hopefully for that planned piece of activity? Is it documented? All those things were issues. Multiple part numbers for the same part. We have substitutes, but maybe the substitutes don't recognize each other. The way design engineering worked, they weren't really looking at what was already in stock, and they were creating new parts. one single prime supplier. That they thought that was a challenge, that that's what they wanted perhaps. Timelines and pricing, not a good option, but perceived only option to go to the prime supplier. Optimizing parts, stocking policies. Well, I mean, that's probably, frankly, where the main focus is for anybody who ends up playing the role of an inventory planner. And then inventory integrity issues. The system says I have 3, I only have 2, or I have none, that kind of thing. Too many opinions on what should be stocked, where, validate the part number, and the order priority. So that gets back to, John, your question about, well, what do I stock and when? Well, just go ask 12 people. You might get 12 different answers. And so that, frankly, is a lot of the issue. And then if we were to run this as a course, as the 2-day course, I might say, well, what do you hope to get out of these 2 days? And I don't have a standard answer for that. I bet I did get them, but I didn't publish it in this 1-hour presentation. So what we have actually come up with is 10 elements of things to focus on specific to maintenance parts management. Foundationally, it's strategy. So we have a business strategy. Our business is in place to create value for a certain reason. And so we have assets there to create value against that business, to create service value or supply chain value. And what's our strategy to support that? And our strategy to support that should also have a parts strategy to support that. So business strategy, maintenance strategy, parts strategy. How are we organized to deliver on that strategy? So that's the management component. How do we physically deliver that? And that's the logistics. So that's the inbound, the warehousing, and if you like, over the counter and stocking, preparing for stock. There are lots of charts now on LinkedIn where you see things like, oh, well, we have a culture of supporting planning and scheduling, therefore we have kitting. And so that might be part of logistics. Well, not might, it would be part of logistics. How do we measure success? So that'd be KPIs. And then it might confuse some people, but in my experience, then you'll see the term inventory planning and inventory optimization, and then asset, LC stands for lifecycle integration. There's a lot of things here. I've called the inventory planner a separate role, which frankly is very much an operational thing. And then you've also got systems and data to fuss with. You've got procurement and potential parts repair to fuss with. You've got asset lifecycle integration, which I would actually suggest is the initial spare parts, recommended spare parts, algorithms could fit in there, along with, what's our strategy before we actually put the asset, before we actually install the asset, to while we're installing the asset, while the number of assets grow, through to end life of assets, and we start to diminish the number of assets that are installed of the same type. And then the notion of inventory optimization. How do we take whatever we've got as a network of parts and our program that suggests that we have to drive value in our supply chain, and how do we support that, and how do we optimize inventory such that we don't hurt the service levels, but we minimize the inventory and keep everything close to where it is needed to be. And then ultimately, we have process redesign. So how do we take all those things and perhaps culturally break it or culturally improve it so that we can't break it so we can improve it, is the point I was trying to make. So originally we had this maintenance parts excellence pyramid. It was derived from a maintenance excellence pyramid that came out of John Campbell, which was a Heritage PricewaterhouseCoopers gentleman that when I was at IBM, we used a lot of. And so we're basically using the same kind of pyramid and the same mindset. That's kind of where my head was organized. So we have leadership things, which are strategy and management. We have the things that the average technician can control, which is procurement, repair, and data management, and inventory planning, and logistics and measures. That's generally what the staff can control and the line management can control. And then you've got things that require cross-functional people to work together to be successful. And so that's been branded continuous improvement. And so that's the notion of asset lifecycle integration. And it's also the notion of inventory optimization. In other words, you're not going to say, let's get rid of these 10 part numbers without a community agreeing. Or on the other hand, we shouldn't be saying, let's put in double all that without the community agreeing. And part of that community includes finance. So we need to understand all those dynamics. And then how do we do quantum leaps? Well, you do that through some sort of redesign. Obviously, you want to do this across the asset life cycle, and how we drive the asset life cycle, and how we can improve on all these things. All right, so some simple truths about the role of the parts manager and parts management. It's not just what you see at the counter. You might go to the counter and go, okay, that's what I got, these guys, they're going to go get the part for me. And that's all I think about. Well, there's a lot more that somebody had to think about for that part to actually be on the counter. So I'm going to take you through some leading practices, things that would typically be in some of those elements, some of those 10 elements of that maintenance excellence or that maintenance parts excellence pyramid. One is corporate mission, vision, goals are clear and aligned to maintenance parts. And I'm not going to read through all these. As I said, you can look through them in your leisure. I'll send you a copy of this if you wish. But notionally, the second last bullet, organizational ownership of the maintenance parts inventory management policy process and handoffs are clear. The handoffs are clear. The main one I highlighted here is who the parts group serves is clear and tenaciously pursued. That's probably the biggest issue. I've walked into organizations where, depending upon who the parts organization reports to, the behavior is different. And I would suggest to you, it really doesn't matter who they report to, as long as the behavior is correct. And we just have to make sure that the behavior is correct. And the correct behavior is that we have the right balance of having the right parts that meets the business strategy, which obviously the business strategy has to meet the maintenance strategy. So why is maintenance parts management important to your enterprise? Well, an example would be that you have to clear mission, vision, goals. So you see an example of a mission on the left-hand side, and decide why you exist. And why you exist might have some leading design principles in there. Driving to continue to support the organization's corporate mission. So everything has to be aligned. Continue to support day-to-day logistics execution. Policy design, leveraging stakeholder participation. Bottom line is you have to make sure why you're there. And let's make sure we drive it and make sure the executives all line up. You don't need executives wanting to beat on each other over this. I don't know how many times I've had clients send me emails. Oh, Don, you said that shouldn't report here. No, I didn't say that. I said it shouldn't be reporting there if the behavior is. And so we really need to make sure that the behavior is aligned and everybody understands the role they're going to play. So I've seen situations where the parts reported to finance and finance thought it was good to minimize inventory. Well, that's all right, as long as you're still serving at least as well, if not better than how you were serving before you started to reduce inventory. So that's the kind of behavior balance we need. One of the questions I wanted to answer is, who does the parts group serve? Well, it serves a number of different folks. And you've got a bit of a process here where you say, well, I've got my central warehouse and I might have a local stock room, and eventually through the technician, it gets to the asset. But some of those parts might have residual value that could actually be repaired. And so we need to keep track of the used parts. We need to be able to bring them back into some sort of repair cycle. Obviously, we need a good relationship with our relationships with our vendor. If the vendor is the repair arm, or if we're doing it internally, we have to have the ability to scrap parts. We have the ability to manage surplus and even sell surplus, so we don't lose 100% of our purchase when we're getting rid of surplus. And we need to optimize all that inventory. So that becomes fairly dynamic. And then think about the notion that maybe your local stockroom is 20, 30, 60 stockrooms, not just one or none. And that's what makes it very complex in terms of, well, where do I stock those parts? So who do I serve? Well, the business function and operations, maintenance process technicians, parts repair staff, maintenance inventory staff, procurement, design engineers, finance, audit, even the environmental folks and the health and safety folks. So it's not a short, this is not a full list. It's actually a short list, but it's quite a large group. And who can contribute to parts management success? It's really virtually every one of those folks. Foundationally, to understand where parts fits, and I often use a water bottle as an arrow. If you look at this and kind of go, well, if this is my asset driving value in the supply chain, I have a bunch of assets driving value in the supply chain, and maintenance has its role to play, then parts has to support maintenance, because it's pretty hard to fix something without the parts you need. It's pretty hard to have the parts you need without procurement. It's pretty hard to procure without accounts payable doing their job. So all these things have to work together. And then notionally understand that if you have an asset, an install base, it's broken. That's my little lightning bolt through there, black lightning bolt. Someone has to dispatch the tech, travel there. They have to diagnose and fix and test and eventually return it back into production. But the notion of maintenance, parts, delivery, and mission is quite complex. We have to anticipate in advance what parts you might need, make sure we put them where you might need them in the network, have the proper stocking of it, maybe have the ability to expedite things, or a little aircraft there to expedite things, get it to you, the technician or the customer, and then also get the old parts back. Many organizations, the old parts become, well, I don't know, don't care where they went. And that's money lost and potentially risk of employees taking advantage of that where they shouldn't in terms of selling things in the market when they shouldn't be doing it. So getting control of those parts and getting them back, getting the ones repaired, turning them back into inventory if we can repair them. So one of the materials management models I wanted to suggest to you is a very, very simple one. It's a block diagram where you notionally look at this, all right, all the outcomes of maintenance parts, and therefore even the KPIs of the maintenance parts might be parts availability, parts acquisition time, systems availability, distribution quality, parts cost, and then some financial ones, inventory turnover, inventory provisions, or inventory reserves. And I try to keep the key measurements to 5 or 6. So the top 5 or 6 are the ones that parts folks would focus on. And then the inventory planners, along with the finance people, would focus on the last 2. So that might be the KPIs, but then you're managing on how do I physically get the parts to you, which is logistics, warehousing. And then how do we physically procure the parts or repair the parts? So that's another block diagram. And then ultimately, how do we manage all that from an inventory planning and policy perspective? And so I tried to simplify what in essence is a very complex situation by leveraging this materials management model. Another way to look at it is if I have my inventory and say that inventory is $100 million in the blue box in there, you got inventory value, turnover, procurement time, availability. What are some of the influences that are driving that? You have asset strategy, you have procurement strategy, you have inventory strategy, but you also have the demand that you're serving and then the business impacts that has. And so those are some of the things that you would fuss with as you're trying to understand how all that might fit together. As I expand that model, as I said, in this case, it's a $55 million inventory with 1.8 turns. Therefore, I've got whatever that adds up to, about 100 and change million of output. But hopefully the turnover is only counting the part sales and usage and not the scrap. So it's almost 100 million in output. And I have a $55 million inventory. So that hence the 1.8 million turn. And then you've got initial spare parts coming in. You've got replenishment coming in. You've got some repaired parts or reutilized parts coming in at 60 million. And so you can explain to somebody your inventory in fairly simple block diagrams and help them understand, in terms of large numbers, what the dynamics are. Of course, these dynamics would change almost every month, but it helps people understand what the dynamics are, what we should manage and where the focus is. Can we afford it at a macro level? And obviously we can't afford just to throw all the parts out. So how do we deal with that? Some of the complexities to parts. Well, I kind of hinted at this model before. We have a central warehouse and a local stock room, and we have assets and used parts returns and vendor supply. So some of the questions you have to answer is, do you have the part in stock? Is it a part you're going to stock at all? Where are you going to stock it? Can I return the part if it's not used? A quality part? Is it a repairable part? Can you kit the parts for planned maintenance? There's a number of things that one might ask. And then you add onto that the notion of, can I support emergencies? Can I get parts cost competitively? What is the delivery quality? What are the inventory? What's your inventory integrity? That's the notion of, it says you got 3 in stock, but it turns out you have 0. So I didn't worry about replenishing because I had 3 in stock, but it turns out I don't. And how do you best dispose of these parts? So you start to get more dynamics here to fuss with, and disposing of parts, especially this day and age, is more and more important as we get into issues with things like environmental impacts and such. Or can we get precious metals off of some of these parts where that makes sense? All of this has to happen while we're notionally thinking about the asset life cycle. That asset life cycle could be the financial analysis, the design, the detailed design, construct, commission, operate, maintain, which is the bulk of what most people think we're worried about when we're talking about parts. How do we enhance the asset while it's out there? Again, we need to change features and get the right parts for those new features. And then eventually we discontinue that asset, and therefore we should be aware of the wear used of these parts and know what parts that we can actually sell as surplus because we're no longer supporting that asset, or perhaps no longer supporting as many of those that are in the field at or before we get into formal full decommissioning. It can get more complex if you have multiple stock rooms. As I said, in my base, I had 21 stock rooms. My colleagues in the US had 65 or 75 stock rooms to deal with in the US. So there was lots of dynamics you had to think about. Well, if the central warehouse, or there's sub-central warehouses, local stock rooms, Do we actually stock parts at the asset site? All those kind of dynamics. How do we deal with that? And so lots of inventory control things that you had to sort out and try and answer. Are we stocking for planned versus unplanned? What are the service levels in terms of our dynamic inventory tracking controls? All those kinds of things. How do we manage the replenishment across the network? Managing quantities by location, stockroom on-hand quantities and transit quantities, work order reserved inventory if we're putting parts in some sort of kitting location for work orders that might happen that week or the following week, stockroom availability inventory, all those kind of dynamics, reorder points and economic order quantities. Lots of dynamics to think about when you're dealing with the algorithms and systems, if you like, around the dynamics of parts. And how do we manage procurement of the network? How do we keep track of all that? So that brings us back to this notion that we have to walk through some of this dynamic of the maintenance excellence pyramid and across the asset life cycle. Brings us to the notion of this materials management model that I've just already shared with you a little bit. The notion of where parts plays, it's there to support maintenance, which is supporting operations in terms of the value that's created by the assets themselves. And how might you decide what you need to go focus on and what to do first? Well, there's a program that we've used multiple times, and it's notionally just taking some questions that were comprised to kind of define what's in the standard, that maintenance parts excellence pyramid, and sending it out to an organization, filling it out, getting a sense for where they feel they are performing currently, having a bit of a leading practices presentation with them, which is kind of what's implied on the far right after we've done the spider diagram, and then presenting what leading practices would be, which usually takes about a day just to talk about what leading practices are and calibrate the discussion, and then deciding what it is they should go resolve and what they should go focus on now. Obviously the low-hanging fruit, but perhaps what are the other things that are going to help them solve that, coming up with a roadmap and ultimately a program map, if you like, 1 year or 6 month to 1 year to a couple of years kind of roadmap in terms of what they're going to do to improve their business. So that's very similar to the one that we've used in maintenance management as well. That was featured in that asset management excellence book that we showed you earlier. It's very similar process, and it works quite well from parts. Here's an example of one that worked at parts where they came up with one idea in green there. It says it was a logistics management idea that basically said it would cost them maybe $250,000 to do, but they would save $1 million if they did it. And that's a minimum $1 million if they did it. And a maximum of $250,000 to do. So some of these things become pretty self-evident that as you start mapping these things out and say which ones you're going to do and which ones shouldn't you do, there's probably the upper left-hand side, there's probably at least 5 things there that they could do that would be fairly significant input or impact to that very, very small business. This was an organization that didn't even carry 10 million in inventory. So you could see that to them, that would be a very significant benefit. So as I look at the materials management models, the ones I've already shown you and how some of these models might fit together, another thing to think about is one of the objections I used to get because I was the maintenance parts manager at IBM is the people that were at IBM that were manufacturing product would go, oh, parts, they're kind of like manufacturing product. We do that all the time. We know how to manage product. We know how to bring things together and assemble them. We have warehouses, you have warehouses. We should maybe cram you together. And what I found myself saying is the only thing that maintenance parts and manufacturing have in common are washrooms and parking lots. The truth is that the manufacturing process has to go through design and develop and plan the product and make decisions about make or buy and assemble it and deploy it. And it's all done based on supply chain demand that they forecast. Whereas in maintenance parts, it's pretty difficult to forecast the demand, especially on things that are going to fail randomly. So at some level, we have to, through the whole asset lifecycle, come up with a way to recognize the demand, forecast the parts, source and procure the parts, decide where we're going to stock it, and deploy the part from that location where we're going to stock it, and then give it to the technician. So that's a service the asset. Find a way to get the parts back because we're going to also help disposition the old parts or repair the old parts and get rid of the ones that can't be repaired. And it's really all about this asset install base, which if we have good reliability center maintenance data or other kinds of data, we might have some good insights. Even mean time between failure data is not that helpful in terms of helping you forecast what part you might want to stock. I used to tell people that managing maintenance parts was a little bit like having a teenage daughter. And I apologize if this sounds a little bit fatherly, but I remember saying to my daughter this story, and she actually agreed with it. My daughter once said to me, "Dad, why do you travel so much?" Because I was traveling a lot, traveling around the world, hardly ever home. And I used to say, "Hon, I travel so I can make money and give it to you." And she thought about it for a few minutes when she was 12, came over and gave me a hug and said, "Keep traveling, Dad." The reality is everything we do is all about the asset. Everything you do is when you make a decision, perhaps to travel, as I did, was presumably for my family. And so everything we're doing here is to come up with a strategy that's going to make that asset available so that asset can drive the value that it's supposed to drive against that company's primary mission. So you have some roles to play in terms of manufacturing, but the roles to play in maintenance are quite different, and the part support to support that maintenance is quite different. And I would make sure you don't get caught in that. When you look at management, now, who are the people in management that have to help the success of a maintenance parts? Well, it's all the people on the right-hand side. It's operations, it's maintenance, it's your vendor, it's procurement, it's design engineering, it's finance, it's legal, HR, IT, particularly IT, and all to help that maintenance parts organization make this work. And so the bottom bullet I have here is all enterprise business entities fully understand their role and influence and ensure a leading maintenance parts operation is successful. That's what you have to do. If anybody thinks, oh, well, I don't know why they don't do it. The way I would argue is if I don't have the part in stock, it's a little bit like your spouse saying, you should know why I'm angry. If you didn't tell me I was supposed to have that part in stock and I didn't have the right understanding and balance against the business strategy, then likely I'm not going to have that part in stock. And so there's a lot of information and communication that has to happen before that part is actually needed to know whether I should be stocking it or not. And so we will talk about some of the dynamics of that, but this is just an expanded view of the same chart. If you look at, well, who are the stakeholders in maintenance parts excellence? Well, it's the inventory manager, it's the warehouse manager, it's procurement manager, it's the maintenance technician, the operations manager, the design engineer, the finance manager. And I've listed a bunch of goals. And if you notice, the goals are all quite different. And so it's really hard to take one person and say, why should I stock that part? You need to find a way in an inventory policy program that will drive the balance to make everybody understand why we're doing what we're doing. All right, so this is a chart that I actually created when I was at IBM and I was still the country parts manager. And to make it simple, we just said, well, we unit source some parts, we have inventory management, we deliver parts, and we measure what we did. One of the things that wasn't obvious to me then as much as it is now is we actually stock parts for unscheduled demand. We shouldn't be stocking parts for scheduled demand. If I know that we're going to go out and do this thing, whatever it is we're going to do, and use a ton of parts, well, why don't I order them in as I need them, a week before? Why do I have to stock them all year? And so we need to get people understanding you stock parts for unscheduled versus scheduled. That's the first part. And then also understand how do I get the parts to you? So there's things like kitting and better delivery and all those kinds of things, which we just don't have time to get into now. There's lots of system things you can do, but also recognize from a procurement perspective, you can go to the original equipment manufacturer, you can repair the part, or you can tear down old assets perhaps you don't plan to use anymore. There's lots of different ways to get parts. As well as you go deeper into this unit sourcing component here, you realize that there could be some content management issues. Do we have the right description of the part? Maybe I have the part, but I can't find it because we haven't described it well. Do I have substitutions? Boeing actually had, I think it was 164 or something like that, different part numbers for the same bolt. So how do you find a way to consolidate all that and make it work? So as we look through this model again, the KPIs, the logistics, the inventory planning, and procurement, and if you focus on logistics, you can see here that the logistics folks themselves have a bit of a task to understand, well, how am I actually going to receive parts that come in, put them away, pick the parts, maybe replenish either internally or other stock rooms, or if you've ordered something for an existing work order, how do I flow through and get it to the work? And so there's lots of dynamics that one has to do even just behind that counter, that arguably has very little to do with what part to stock. This is just getting it from what I would say dock to stock, from getting it from, all right, it showed up at the dock. How do I get it to a point where I get it to make it available to the technician? So there's a lot of dynamics to fuss with there. All this has to be supported by the inventory planner and management and staff and performance management. And to expand some of those things that we showed you earlier, in the previous chart, there's the emergency cycle times and kitting and delivery strategies and reverse logistics and echelon management, which I haven't actually explained echelon management yet, but to give you a sense for that. I had a client in the Caribbean that I took a lot of pictures of, so I borrowed a few of their pictures over time. We did both a maintenance assessment and a parts assessment there. And some of the things I noticed is they had parts that were rusting on the shelf. You see in the lower corner program. Their stockroom actually didn't look that bad, but maybe could have been tidied up a little bit more. But they had open access. And so, well, who's accountable if parts are missing? If people can go all hours of the day and walk into a stockroom, that's an issue, or could be an issue. They had a saltwater island kind of environment. So it was very simple. It's very easy for parts to rust. And they had to do some environmental things to improve on that. They're still working on that, but the truth is right now they spent a lot of time taking those parts and packaging them into containers that would suck out the air and the moisture so that they wouldn't have the issue for rust that they hadn't really addressed before. So there's a lot of issues to think about just in terms of what you've got to do in the warehouse. You got to think about where are the parts compared to where they might be outbound. So I might want to do some bin trip analysis to optimize my parts picking. Their particular parts were marked at the bin, but not necessarily marked at the part. So and labeled, that is, they weren't labeled at the part. So when the technician got it, they weren't sure they got what they asked for. So they had a few things to fuss with there. And they had to decide who was owning expediting. Well, we don't have the part. Is that an inventory planner's problem? Is it a maintenance planner's problem? Who is it a procurement problem? Who owns expediting parts? So something to think about. When we look at KPIs, and I'll just go through this quickly because I already talked about some of these KPI notional things. You just got to be able to understand some of that demand, understand that you're managing for unscheduled demand, mostly not necessarily scheduled demand, and you're measuring those KPIs that I showed you earlier about parts availability and acquisition time and systems availability and distribution quality, et cetera. And also note that your KPIs could be different depending upon who's looking at them. So the executives, might look at a very high level. Well, I have this kind of service level, I have this kind of inventory, and I have this kind of turnover. You've got your senior management that'll be looking at other things. You've got your technicians or your senior staff looking at functional things, and there'll be other folks in the industry that'll be looking at the actual asset performance. So lots of different dynamics in terms of how you might dissect what you want to measure for a particular KPI. And again, not to get into this because we just simply don't have the time, but to think about the kind of KPIs that you want to fuss with as you go back from the actual delivery of a part on the right-hand side that goes to the craft. What are some of the metrics for ordering versus some of the metrics for the warehouse versus some of the metrics for repair versus procure, use parts, for instance, and then some other metrics that the inventory management folks might look at. So it's very common to say at the order, well, if you come to the counter and ask for 100 parts, what's the likeliness is I'm going to have all 100? Presumably, you might have 85 of the 100 or 90 of the 100, hopefully not 40 of the 100. And so you're looking at some of those dynamics. But even if you have them, I want to make sure it's the right part, the right quantity, the right place, and the committed time. So there's some logistics quality in there. Inventory accuracies and inventory variances are minimal. So this could be a bit of a walkthrough in some detail. And if you're looking for a sense of some of the things you might look at that were published by Aberdeen, now this is a bit of an older chart, but to give you some of the things you look at here, they're saying, well, if the technician went out to fix something, they would fix it approximately 90% of the time first time. Well, they're going to fix it 90% of the time first time. They need to be supported by having parts. And so you can see some of the things that they'd be looking at. Distribution quality, 99.8% of the time. That's the right part, the right place, and the committed time kind of thing. The actual part working, 99.9% of the time. I've learned, back when I did this, Six Sigma was a common term, but the average warehouse person couldn't relate to Six Sigma. So we started using 99.8, 99.9, 99.95, and they could relate to that for some reason. So that's what we ended up using. warranty recoveries. They were able to recover about 80% dollar value refurbishment versus new parts procured. So that's the notion of actually recovering money from repairing defective parts versus buying new, those kinds of dynamics. Okay, if we look at inventory planning, and John, this is probably the complex answer to your simple question. The dynamics become there are multiple swim lanes of how you support a part. From a supply chain lifecycle perspective, before you bring the asset in, you want some initial spare part mindset or recommended spare part mindset. Notionally, every part that you would ever expect to use on that asset should be in your maintenance system, should be in your EAM or CMMS system. And then you say from that list, say that's 100 parts, what parts do I expect I might use that would keep my asset down? And maybe that's 30 parts. And then you start thinking about, well, of those 30 parts, dollar-wise and other things and risk as impacts to the business, which one should I put as an initial spare part? To complement that, you might say, well, there are certain parts we're going to use fairly often. We're going to use certain parts multiple times in a 2 or 3 month period. And so I say, okay, well, we'll start to have a min-max and economic order quantity view of those kinds of parts. We'll have some other parts that we use some and we didn't use some. So we used one about 6 months ago. We used another one a year ago. What do we do with that? And we'll have a strategy for that. And I'll skip the dynamic inventory optimizer for now. You'll have the notion of substitute order points where maybe the technician can say, we're so far remote from the central stock room, we have to have some different kind of support. And then, of course, we have to replenish. And then we know that some parts go out, some used parts are going to come back in. And so there's a fair bit of dynamic there. And the way I look at this is swim lanes. The initial spare parts, the highly active parts, the data activity parts, and the optimizer parts, and the substitute order points are just different swim lanes. And then ultimately, you set up an algorithm to pick the one that best suits your situation, which usually is whatever the highest recommended policy is. So that's notionally the so-called, my attempt to give you a simple answer, John, to your question. Although if you go down every one of those lines, there's a complex algorithm behind each one of them. Of course, when you get into the systems, there's a lot of things to fuss with in terms of data. You need item master data, you need inventory stock tracking data, you need inventory disbursement data, finance data, and procurement and repair data. Now, some of you might know at one time I was a global Maximo guy for IBM. This list is not necessarily a Maximo list. This is actually more from an inventory planner's list of the kinds of things that I would need. And to be quite frank, I suspect Maximo didn't carry a lot of that data out of the box. But the notion is that you want to look for something like that to have that kind of data that you can start to make some dynamic decisions on. And then you can look at what's my max stock, my average inventory, my reorder point, my min stock, my safety stock, what's my economic order quantity, or lot sizes, if lot sizes have anything to do with what we're doing. And it's really about data, and it's really about communication and getting information from the technician if they're ordering things. And from a procurement perspective, you may be thinking blockchain. Like there's just a number of dynamics there that you need to think about from a data perspective. And so to be successful in this space, boy, you got to have systems. I mean, and it's really only 1/10 of the equation in terms of the way I've presented it in that maintenance parts excellence pyramid. But there's a lot of data that's required there. And of course, some of that data might be out in the cloud. Then we go to procure and repair. Typically, your procurement person is managing strategic commodity sourcing and supplier relationship and transaction execution. I do not expect procurement to tell me what parts to stock. I expect the inventory planner in that community, but they still have to help us execute that. They have to help us understand the right commodity sourcing and manage the supplier relationships. And so there's a role for them to play, as well as maybe negotiating that we only have 1 or 2 part numbers instead of 148 or whatever the number was for that bolt that might have been at Boeing. So there's a number of things for them to do. And then when you look at realizing parts, the notion of used parts returns, management, parts disposition, parts repair capture rates, repair yields, out-of-box failures, second return rates, a number of KPIs that they would look at there. Okay, and this is an expansion of the procurement chart that I talked about as they look at supply activities and your internal activities. So going back to this chart that I showed earlier, that's a summary of it. Now we're going to move on to asset lifecycle. And I kind of hinted at this when I talked about the notion of picking up your initial spare parts. Basically, all parts that are reasonably likely to be used in the asset lifecycle should be on the parts item master in the system. Design engineering provides an initial spare parts recommendation to the inventory planner, and they set that before commissioning, and it's got to be agreed to by finance. Design engineering and finance have agreed to what that list would be. And once they've agreed to it, the initial spare parts, in my mind, gets rebranded recommended spare parts. That's just a way of saying the design engineer owns it versus the maintenance team owns it, or the operations and maintenance team owns it. And then somebody has to decide who's going to own the end of life strategy for this asset, which in many cases might be the design engineer through the whole business, or it might be the design engineer pass that over to somebody else in operations, but somebody has to own the end of life strategy. And so there's a lot to be negotiated up front. If it's not negotiated up front, pretty hard to expect it to magically work in the middle. So this is a lot about the asset life cycle and how you need to deal with that. And of course, it's a lot about data. It's also notionally understanding that, you may, if you're going to put in multiple cycles of the same asset, that there's going to be some early new build. And as you start to build more of them or put more in, the peak for certain demand is going to happen at some level in its asset life cycle. You're going to improve maintenance, and so the need for those parts will hopefully shrink. You're going to modify the equipment, so the need for some of those parts might change. And you need to be able to forecast some of that right across the whole asset life cycle. So there's quite a bit of fussing to do there. And so one of the experiences I had with one client was you could get finance and conceptual design and functional design and detail design and construct and fabricate, but they couldn't quite agree on when they handed it over during commissioning. And so we came up with this notion, well, you can hand the data over here and you can hand the ownership over here. And we saw it off on that, but it doesn't have to be exactly that, but that was one example. And I think I got design engineer or the field service and design engineers own. So either design engineer hands it over and goes on to do something else when maintenance starts, or they own it through the whole asset life cycle. That's the difference between those two charts. All right, now I know I've gone through it pretty quick, but we don't have a lot of time left, so I'm going to continue to go a little bit quick. Inventory optimization, inventory dynamic optimizer. That's a notion of putting a whole lot more data in there and starting to circumvent some of the other swim lanes and say, look, we can put some other data in here and talk about how things fail, how they operate. Maybe that's where we look at operational data. We use this inventory optimizer tool to have an inventory optimization challenges where someone says, like, it's all good, but how do we do this with less inventory? And it will take things like, well, here's your recommended spare parts list or initial spare parts list. And it might take the most expensive ones that you're not using very much and say, well, let's take 2 or 3 of those parts out of the inventory and let's put more of the cheaper parts in that you might use. And it's amazing how statistically that actually helps your inventory and your service levels and keep your assets running. So those are some of the dynamics. The optimal inventory policy could be a number of the things listed here. What is the inventory policy? What are the variables that can be included in the inventory policy for each stock keeping unit? You need to think about where you're going to stock the parts and what level you want. So do I want 55% close to the asset and 85% of the local stock room, 95% at the central stock room? And then notionally, ultimately you get to, well, if all of this is working, I've thrown a lot at you. If all of this is working, how do we break it, assess, analyze, and execute some solutions to improve that? That might involve some sort of total productive maintenance culture, some sort of total quality management culture, probably involves a number of other things that we're very aware of, like 5S, those kinds of things. Now, I want to remind everybody that no one should ever forget that the reason we have assets, the reason we're in business is about money. So there's never an unlimited amount of money. There's never unlimited amount of deep pockets. And every year that you keep a part in stock costs you about 30%, 25 to 30% a year. So it's not just about, if I have $100 million in inventory, oh, well, I already bought it, so what's the big difference? It's, I have $100 million inventory, and that $100 million is costing me it's cost me 25 to 30 million rather dollars a year just to keep it. And so some of those real dynamic costs have to be fussed with against the cost of the overall business. Ways to measure your effectiveness. I've shown you some of these models, or some of the models that you would look through to use to try and explain your inventory. What's the big picture? Which picture would you bring to your executives to justify your maintenance parts? You could also talk about inventory turns, which I think is a very poor measurement for optimal inventory. You could talk about asset value support, which is probably a little bit better in terms of I have these assets. Here's what it's creating for value. Here are the parts we use to support it. There's another argument for net materials management process costs or asset value. And then I just showed that chart again. Here are the different models I've thrown at you in the course of the last hour or 55 minutes or so. Fortunately, we don't have a lot of time to go through that, and I'm going to pause and see what we have if we have any questions. And I apologize, I went through that really quick. Comment, parts challenge. A warehouse might have different parts with the exact same description, making it hard for text to filter. I agree, for example, filters. So you need to sort through some of that. You need to kind of say, how are we going to define it? Can you tie it to a piece of equipment? You need to label it such, and there's lots of ways to do that. There's lots of description capabilities depending upon the CMMS you're using to be able to do that, but you need to be able to do that. Some systems actually allow a picture that you can use to help with that. So if you have the ability to have a photograph in there, that might help. John, thanks. Excellent. I'm wondering if you will talk about job descriptions. I will not be talking about job descriptions, but we could talk about that offline if you wish. Give me a call. I'm happy to talk about that. Auto spare part flag is significant. And use commodity code for failed component. Or you use the commodity code for a failed component. Okay, I mean, yeah, so maybe we'd have to talk about that offline, John, as to how you do that, given the time. But regarding part criticality discussion, I would have mentioned asset criticality. Yes, asset criticality is, well, that's part of it. I mean, you're talking about critical assets, and you're talking about what's the affordability for having it down, and that's going to have some influence on your initial spare parts or recommended spare parts in the way that I position this. What guidance would you give parts as it relates to current global supply chain breakdown? Not sure how to answer that, June. I mean, parts is really about keeping the asset running, okay? And so it's quite a different supply chain than typical product supply chain. And so you got to look at the value proposition for the asset itself and how am I supporting that would be the simple philosophical answer. Any other questions? We just have a couple of minutes. Anybody, maybe I'll just pause the chat here and let people think about it while you're doing that, because we're probably at time, but I'll just add a minute or two since we started late. So U of T, the University of Toronto course that I teach is coming up on November the 15th. The parts course is coming up on November the 22nd, and the IT and IoT course. So I apologize for going through that fast. I think in hindsight, I probably could have taken out a half dozen at least of those charts. Are there any questions? You're welcome to unmute your phone if you have a question that you'd like me to address.
Yeah, Don.
Yeah.
My other question is really also, does one decide to maybe take proactive action to stock up on more critical parts if one wasn't sure, didn't have a clear outlook as to when the supply chain breakdown might ease up?
Yeah, okay, I see your point. All right, so the answer to that is perhaps likely, yeah. I mean, what I didn't get into too much on the procurement side is you need service level agreements from your suppliers. And often the lead time and the amount you stock is your perception of lack of trust of them actually meeting that commitment. So there's a dynamic there where you can possibly hold their feet to the fire, but that doesn't help you if your asset's down. So you may want to bridge that by stocking some additional spares. I mean, that's certainly an issue. The other issue is you may find out that they're not manufacturing anymore. So now you have to start thinking about, how do I stock this for the whole asset life cycle? Or perhaps more appropriately, how can I refurbish it so I can actually have that part cycling within my own enterprise and reutilize it on the expectation that I can refurbish it to be statistically as good as new.
I have a question, please.
Yep.
Yeah. Okay. Actually, I have also a question regarding the life cycle, cost analysis, but from operational perspective. Like sometimes I don't have like much details or much information from design perspective that can help me to build the life cycle for the assets. So how I can deal with that? Is there any way that we can actually, get this kind of information so we can build the life cycle analysis from operational perspective?
Well, I mean, to me, the best way to get data on what you think the asset failure operational impacts needs are and where used and operating context and everything like that is to have done an RCM analysis. That's the simple best answer in my mind.
Yeah.
A lot of people may not have done that, but that would be the simple best answer. Alternatively, you go back to the manufacturer and ask them how they expect things to fail. And this is the breakdown I often get from when I walk into clients is the design engineering people who might have set up that asset to be installed weren't really charged with going and getting that information. So therefore, when you go to commissioning, you don't have that information. And so it's a matter of getting everyone to understand what their roles are and what they need to do to make parts successful so that maintenance can be successful, so that operations can be successful.
Yeah, I always find this as a gap because all my experience was in oil and gas and petrochemicals. And often, actually, we already got all this, assets, and it's already running for like 10, 20 years.
Yeah.
And then you need to do this kind of RCM or FMEA or whatever the tool that you're going to do just to identify this kind of analysis. But yeah, you're right. Yeah.
Well, I'm an RCM2 practitioner, so I'm a little bit bigoted when it comes to the RCM. I'd prefer to see somebody commit to that than just a failure modes effects, analysis. But I get what you're saying. Maybe if there's no more, maybe one more question. We're 5 minutes over. One more question, and we'll close it out. If there's any more questions. No? Okay. Well, listen, we've had, I think, about 11 or 12 people on here for the bulk of the time. I really want to thank you for sticking with it. As I said, I will send out a copy of this presentation to everyone that participated and ask that you give me a couple of days to put this out on video. It'll be out on YouTube probably by Saturday. And thank you for listening. Hopefully you found value. Love to hear your feedback. And don't be shy. If you want to talk about something, send me an email. Happy to schedule some time with you. I often learn, if nothing else, I learn the kind of questions you have if I don't actually learn some insights from people as well. So I'd love to hear some of those insights. Thank you very much. And I will thank everybody for attending. Take care. You've been watching the Maintenance Parts Management Challenges Asset Management webinar, sponsored by Asset Acumen Consulting. For further information, check out Asset Acumen at www.assetacumen.com. Thank you for listening to this webinar.